Congestion is an unwanted yet unavoidable phenomenon in data communication that occurs due to excessive data generation by nodes in the network. It is unwanted yet unavoidable. It means that unwanted because the congestion, it affects the network performance negatively. Unavoidable, it cannot be eliminated. But still, the network design always tries to minimize the congestion in the network. In this video, we wanted to explore what is actually congestion and how it occurs. What is congestion, how congestion occurs, and what are the steps to avoid congestion. Since we have already stated that it cannot be totally eliminated, but we can minimize or we can control the congestion taking some special steps in the different phases of data transmission. This video highlights, or this video focus to understand the basic terms of congestion and accordingly what or how the network should react in case of congestion or occurrence of congestion. To understand the concept of congestion, let us have a look at the network topology. Let us have a look at the network topology shown in the figure. Here the network comprises of three different routers, R1, R2 and R3. Then the routers are connected through To understand the concept of congestion, we have taken an example network where there are three routers, R1, R2 and R3. R1 and R2 is connected with a link capacity of 1000 bits per second. R2 and R3 is connected with 1500 bits per second capacity link, and there are four different source of data, H1, H2, HT and H4. All of them are connected with 1000 bits per second link, and apart from that, the R3 is connected to the destination. There is single destination. We are assuming that there is only single destination to whom all the sources are transmitting data. The connection between R3 and the destination host is 1200 bits per second. The rate of the data generation for all the sources are considered as 500 bits per second, and with that network topology we will see how the congestion occurs. Suppose that host 1 has generated one packet, host 2 also has generated another packet, and these two packets will flow to this router. And also we are considering that size of each packet is 500 bits, and both the packets, when arrived at R1 will forward it to R2 using the connected link, which is of 1000 bps. In this case, suppose that total bits here is 1000 because two packets are transmitting, which is 500 multiplied by 2. So the capacity of the link and the capacity of the size of the packet is same. So these two packets will be transmitted to R2. The R2 will transmit the packet. Since the size here or the link bandwidth is 1500 bits, there is no issue in transmitting these two packets, and that way these packets will reach destination through the designated line R1 to R2, R2 to R3, then R3 to the destination. So destination has received the data, and this data is nowhere stuck or nowhere being queued, because the capacity of the link is sufficient to transmit all the data generated by the source H1 and H2. Now let us see the next scenario. Suppose in the meantime H3 and H4 also has started transmitting data, and again these are of 500 bits packet size. So when it reaches R2, at the moment of time, we are assuming that all the packets are receiving R2 together, 2 from H1 and H2 and 2 from H3 and H4. So these 4 packets, when it reaches the router R2, it has to forward towards R3. And there are 4 total packets where the size is 4 into 500, which is equals to 2000. However, the size of the transmission link connecting R2 and R3, it is only of 1500 bits per second. So that is why one packet need to be queued. One packet could not be allowed to go through the link R2, R3 at the same time. That is why one packet, any one of the packet, will be kept in the queue, which is maintained in the router R2. Then after some time, when the link will be free, means any one of the packet, if it reaches R2, then it will be sent to the router R3. Again, it happens in R3 when it receives, say, 3 packets, 1, 2 and 3, but capacity is only 1200, so one packet cannot be forwarded because of lack of the bandwidth. Now this concept, this process, generation of packets by all the sources increases. If it increases, then it will lead to a different scenario. Now suppose H1 and H2 are generating more packets of similar size. Here 4 packets are there in the router R1, out of which only 2 packets are transmitted, 2 packets are queued. Similarly in R2, due to the packets coming from H3 and H4, more packets are available with R2 which cannot be passed through the link, and it will queue the packets. So some packets will be queued by R1, some packets will be queued by R2, then same thing will happen in R3 as well. Packets are stored in the queue. This queue will take some memory, and that memory will be used as a buffer of the queue where the packets will be stored for future transmission. Over time, when these sources of data generates more data, then size of the queue will be increased. But however, for each of the queue maintained in different routers, R1, R2, R3, and the size of the queue is limited. This is called limited sized queue. The size of the queue is limited. It means that when number of packets exceeds the size of the queue, then packets will not be allowed, or the router will not be capable of storing any more packets here. Then what happens? Let us see what happens when this process continues and the source of data generates packet indefinitely. If such scenario occurs, then the queue will start dropping packets from the queue. If such condition happens, if such condition occurs, then the routers will start dropping packet from the queue. Here the queue is, at this point the queue is full. That's why the packets are start dropping, and this packet dropping is called the loss of packets due to no space in the queue or queue full. If packet drops in the network or the destination, he might be waiting for certain packet and that packet is not arriving so far, and that's why it has to wait, and it will lead to delay in processing. If delay of processing occurs, then experience degraded quality of services. So definitely the degraded quality of service is not the expectation or not the requirement or acceptable to the end users. That is why the network need to take care of such situation in an efficient way. In order to improve the QoS to the end user, it is the responsibility of the underlying network architecture to handle such unwanted situations. Mainly, this kind of situation or this congestion is taken care of in two different layers in the network architecture. One, it is in network layer, and another it takes in the transport layer. And the protocols in the transport layer like UDP, they do not take care of such congestions. However, the TCP, which is considered as a reliable protocol and guaranteed service protocol, it takes care of congestion in a better way. Let us see how to control the congestion. Here, router R3 has noticed that the packets are being dropped from its queue. So as a consequence, the R3 will come to know, or he will realize that there is a congestion in the network. That's why the packets cannot be passed through this link from R3 to R2 or any other link associated to it. That's why in order to stop the packet dropping, he can do one thing. He can inform the immediate router R2 to not to send data immediately to R3. And it may also request R2 to send data only when the packets are being transferred from R3 queue to the next hop. Similarly, if this R2 obeys the instruction given by R3, then he will stop sending or forwarding packet to R3 and he will start queuing the packets in its own queue. The same thing will happen here, R2. Once the queue is full, the packets will be dropped. Again, this R2 will inform R1 to stop the packet transmission, and he again, R1 will start queuing packets in his queue. And then R1 can send the same information to H1 and H2 because there are packet loss here in R1 and they are requested to stop, not to send data till further clearance of the queue in R1. The same thing will propagate in the reverse direction and we can control the congestion. The same process can be also done. Suppose that HD, it is coming to the notice of the receiver or the destination H3 that the packets coming into it is suffering longer delay. So it can realize that this H3 is suffering from delay maybe due to congestion. So what HD can do, he can inform not to the nearest router, rather he can inform directly to the source of data generation, that is H1, H2, H3 and H4, not to send more data till the congestion is over. So this will in turn inform the source of data and they will stop transmitting data. In both the cases, in the first case, all routers inform the next immediate router to stop sending data. In turn, all the routers informs the source of data to stop the data transmission. In the second approach, the end user or the destination informs the source directly to stop data generation or data transmission so that the congestion could be controlled. In the first approach, where the router informs the nearest router and then it is propagated to the source, it is called the handling of or managing congestion in the network layer. And in the second option, where the congestion is taken care of by the end users, source and destination, it is done in the transport layer. So in short, this congestion is taken care of in two different layers. One is in network layer, another is in transport layer. And in both the cases, main intention is to inform the source to stop transmitting data temporarily, or reduce the transmission rate, reduce the data transmission rate. So both the way, either in the network layer or in the transport layer, they try to control the congestion so that QoS or quality of services could be improved for better utilization of the network. This is all about congestion, and different protocols are used in the network to control such congestions. The method which is used in network layer, one of the method which is used in the network layer, which is called choke packets. Choke packets is one of the oldest and very simple method of handling congestion. And in the transport layer, the TCP, Transmission Control Protocol, uses the concept of congestion window to handle such congestion in the network.